Welcome. Today we'll explore the relationship between the angle of a ladder and its distance from a wall. Let's start with our setup. We have a 10-foot ladder leaning against a vertical wall. Let's define our variables. We'll call the angle between the ladder and the ground theta. Let's call the distance from the wall to the base of the ladder x. And the height up the wall where the ladder touches, we'll call h. This forms a right triangle where the ladder is the hypotenuse. Using basic trigonometry, we can write some relationships. The sine of theta equals the height h divided by the ladder length of 10 feet, and the cosine of theta equals x divided by 10 feet. Let's solve for x in terms of theta. From the cosine equation, we can multiply both sides by 10, giving us x equals 10 times cosine theta. As theta changes, x will change accordingly. Let's analyze what this means. When theta is 0 degrees, cosine theta is 1, so x equals 10 feet. The ladder is lying flat. As theta approaches 90 degrees, cosine theta approaches 0. So x approaches 0. The ladder is nearly vertical. Note that theta can't actually reach 90 degrees as the ladder would be perfectly vertical and unstable. In conclusion, the relationship between the angle theta and the distance x is x equals 10 cosine theta, where theta must be between 0 and 90 degrees. This relationship helps us understand how the ladder's position changes as we adjust its angle.